in last video we discussed about uh, more H protonated. Protonated in the sense more H. It could be ionized, it could be non-ionized. Less non-protonated, it could be ionized or non-ionized. Protonated, it doesn't mean it is ionized always. It doesn't mean it is always non-ionized. It could be ionized or non-ionized. See, we can see here example like this is protonated non-ionized, but this is unprotonated ionized. Whereas see, this is protonated non-ionized, protonated ionized, and RNH3 base. It is protonated ionized. See, RNH2 non-protonated non-ionized, but unprotonated ionized. So the point here you have to learn from this slide is that protonated, it could be ionized or non-ionized. Non-protonated, it could be ionized, non-ionized. Now let's learn about physiology, then we can apply to that pharmacology. See here, gastrin releases, sorry, small intestine, sorry, stomach, that releases gastrin that stimulates parietal cells that secretes H plus. This is the physiology. See, small intestine secretes secretin acts on exopancreas. It stimulates HCO3 bicarbonate. So the point here to discuss is that acidic drugs are acidic drugs will be absorbed in stomach. Basic drugs will be absorbed in basic medium. How, why acidic drug absorbs in acidic medium, why basic drug will absorb in basic medium, how it changes, we will discuss in next slide. See, in order to understand, I summarize into possibilities. See, first one is taken acidic drug, for example aspirin. It is a weak acid. Aspirin is a weak acid. When it is dissolved in acidic medium, for example in stomach parietal cells releases H plus ions. It would be non-ionized because drug is the weak acid and medium is acidic medium. Then according to Leach artery principle, it would be most of the form would be non-ionized. So it favors reabsorption as well as absorption. What is difference between reabsorption and absorption? When you consume a drug, if it absorbs from the stomach first time, it is called absorption. When it is goes to while elimination, some of the drugs reabsorb, it means that again it absorbs. Absorption, if a drugs getting absorbing again, it we can call it as reabsorption. If it favors reabsorption, stays for the longer time. See this is the aspirin in the basic medium. It would be ionized, favors secretions because different pH medium. So less drug will stay. If you take a basic drug, for example opiates in a basic medium, it would be non-ionized form, favors reabsorption or absorption, stays for the longer time. If you take a basic drug in acidic medium, for surely it would be ionized and favors secretion, less drug will stay in body. So, what are the acidic drugs? Acidic drugs are barbiturates, ketoconazole, warfarin, phenytoin. These are the acidic drugs. What are the basic drugs? Opiates, local anesthesia, amines, phenylcyclidines. These are basic drugs. So let's understand. We discussed the topic like what exactly acidic drug, basic drug. Let's now apply to our physiology. Sorry, now let's apply. In chemistry, like dissolve like, but in pharmacology, like absorb or reabsorb like. What does exactly it tells? For example, if you take aspirin in acidic medium, already in previous slide we discussed that in aspirin in acidic medium it reabsorbs, so it will stay in blood, but in alkaline medium it would be secrete and it lost in urine. If let's understand this. So where can we apply this? For example in salicylism, what happens in aspirin toxicity, also called as salicyclism. What exactly happens here? Aspirin toxicity. So let's kick out of aspirin, but how? Let's alkalize the urine. What exactly it mean? How? See, aspirin is weak acid. If you put it in a alkaline medium, it would be ionized. Then it can be kicked out from the urine. So, what is the alkaline? Like, how do you change the pH of the medium? By adding NaHCO3. When you add NaHCO3 into the urine, or else when you give a drug NaHCO3 bicarbonate, sodium bicarbonate, it changes pH of the urine. It causes alkaline, so more drug will be ionized and it lost in urine. So NaHCO3 is the hero. So organization of urine, see here, more ionization, RCOH, aspirin, weak acid, it would be more ionized and it would be water soluble. So it can be eliminated by kidney. We can say that it is trapped in urine. That is how we can reduce the toxicity of aspirin. Okay, sir, let's discuss. You discussed about base. Why don't you tell me in why can't we acidify urine? So when should we acidify urine? For example, in weak base toxicity, like for example, when we have to use vitamin C, NH4, how to use? Let's discuss now. For example, mm, ionization of the weak base RNH3 greater than NH2. It causes what it causes. Um, when weak base is ionized, it would be trapped in urine, so it cannot either absorb or reabsorb or not secreted, so it can be lost in urine. How to acidify urine? By giving vitamin C and H4Cl. See, in the case of liver failure, proteins that converted into amino acids, excess amino acid which body cannot use, that can be converted into ammonia, or excess amino acid that can be converted into ammonia. When ammonia cannot converted into ammonia converted into urea, urea is lost through urine. For example, let's think that your liver is not working. When there is excess, see what is exactly liver's function? It should convert ammonia into urine. When there is a liver failure, ammonia cannot convert it into urine. It leads to toxicity. So how can we treat this? By giving ammonia, by giving lactulose. What exactly lactulose does? There is in our there is a gut microbia in intestine. It converts lactulose to lactic acid. When ammonia in the presence of lactic acid, it converts to ammonium, which is ionized. So it cannot cross membrane, so it cannot be absorbed. It is excreted in stool. That is the important role of pH. See, let's understand what if pH is less than pKa, what if pH greater than pK. In For example, if pH is less than pK, uh, pH is less in the sense pH acidity would be more. If a drug like acidic medium more H plus, the drug mostly protonated. Protonated form would be more than unprotonated. For example, take weak acid, protonated form in the sense that here H, more H plus will be there and it would be non-ionized, and unprotonated and ionized. Which fraction would be more? Protonated, non-ionized. Whereas if a drug is weak base, then protonated ionized drug would be more. How I am saying it is protonated? Because here H ions would be more, whereas here see unprotonated and non-ionized. Protonated ionized form would be more in the acidic medium if pH greater than pKa. As already I discussed that pKa is a characteristic value of drug and pH is the medium. pKa is a constant. pH it varies from one region of the body to another. One part of, like in the stomach it would be acidic, in intestine it would be basic. In alkaline medium, pH is greater means like more lesser the pH it would be acidic, more the pH it would be basic. Alkaline medium, less H plus will be there. The drug is mostly unprotonated. Which drugs are mostly unprotonated? For example, if you drop a weak acid drug in alkaline media, more it would be unprotonated and ionized. Why I'm saying unprotonated? Because there are no H present here, so unprotonated and ionized. See here, in unprotonated and ionized fraction would be more than protonated non-ionized. But if you drop a weak base in alkaline medium, protonated CH, protonated and unionized, non-ionized, both are same. Protonated, unionized would be more than uh, protonated, ionized. See, sorry, when compared between these two, this is more protonated, this is less protonated. So unprotonated, non-ionized, and protonated, ionized. So what exactly, sir? How can I determine the ratio of ionized to non-ionized or non-ionized to ionized? How can I determine, sir? It can be determined by pK of a drug and pH of the medium. How, sir? Is there any equation? Yeah, we have a equation. Henderson-Hasselbalch equation. What it tells? Log protonated form by non-unprotonated form is equal to pKa minus pH. By this equation, we can tell that whether the drug is, like how much the drug is non-ionized to ionized. See, as I discussed in previous or in this video, that a small unit between pH and pKa it varies a lot. Like it results into mm, uh, we can see large fraction of ionized and unionized. We can see pH minus pK is equal to 0. What does it tells? It tells that when pH is equal to pKa, 50% of the drug it would be ionized and 50% of the drug it would be unionized. If pH is greater than pKa, then 90% it would be unprotonated and 10% it would be protonated. If pH is greater than pKa but difference is 2, then 99% it would be unprotonated and 1% it would be protonated. If pH minus pKa it would be 3, then 99% it would be unprotonated and 0.1 is, sir, how we are saying 99 point it would be unprotonated, 0.1 be protonated? We all discuss everything. Give me a moment. In next slide, see, take a ibuprofen drug. It is a pain reliever and inflammatory, and it is a weak acid, and it is having a pKa value 5. As I already discussed, 5 pKa value is characteristic of drug. It cannot change. Whatever the medium, it cannot change. pKa is constant. What will happen to ibuprofen in the stomach pH of 2? Let's discuss. Any guess? If you have any guess, any, pause this video and comment. See, pK greater than pH or pH less than pK, both are same, right? See here, pK is how much? 5 minus pH how much? 2. Ibuprofen pK value 5, pH value is 2. 5 minus 2 kitna? 3. Sorry, pH how much? 3. pH less than pKa. If pH is low, it means it is the acidic medium, and ibuprofen is weak acid. Weak acid in acidic medium, it drug is more protonated and it would be non-ionized or unionized form would be more, then protonated or non-ionized uh, fraction it would be 99.9, and unprotonated and ionized fraction it would be 0.1. Okay, this is important for GPAD and NIPER. For example, let's understand with second example. Acetyl salicylic acid. It is a weak acid. It is having pKa. pKa is always constant. I take a aspirin drug and I put it in a duodenum. Just I drop in a duodenum. It is a small intestine. Sorry. Just I drop in duodenum, which is having a pH value 4.5. Now the question is, in a duodenum, what percent of aspirin will be present in a lipid soluble form? 100, 90, 59, 11%. Any idea? Just pause this video and comment. Okay, let's find out. See how to do this thing, sir. Sir, how can I find this thing if we? Oh, sorry. See how to find this answer. Let's understand step by step. If step 1, we have to see that whether it is greater than, like pH is greater than pK or pK is less than pH. pH is greater than pK. Unprotonated form would be more. Since it is a weak acid, unprotonated unionized form it would be more than protonated form. Unprotonated ionized, sorry, in sorry, the pH is greater than pK. What does it tells? pH is greater. It is a alkaline medium. In alkaline medium, if you drop a weak acid, then unprotonated ionized form it would be more than protonated non-ionized. This is the lipid, like RCOH. It is not ionized, and lipid soluble portion will be less than 50%, because here drug is weak acid and medium is basic medium. It obviously ionized according to Lee-Chartley principle. Step 2 is as I said, as I showed in previous slide, pH less than pK. If it is 1, pH is greater than pK, 90% it would be unprotonated, 10% it would be protonated. Protonated RCOH ratio. But how to find, sir? See, step number 3. See, this I made a shortcut, like pH minus pK is equal to 1, 90% it would be unprotonated, 10%. If you want to do and exactly know how much exact fraction it would be, in a question I asked you about lipid soluble portion, how much it would be lipid soluble. I need I don't want less than 50%. I want to know how much exactly, how much percent it would be lipid soluble. Then we should apply Henderson Hasselbalch equation. What exactly it says? Log protonated form by unprotonated form is equal to pKa minus pH. Log RCOH by RCO minus 3.5 minus 4.5 is equal to minus 1. Okay, so log 10, this is a base value. Like if you send here like 10 to the power 1, how much? 10, right? See here minus 1 here, how it becomes plus 1? You reverse, like we guys like reverse RCO minus by RCOH. If you reverse it would be plus. Then this base value goes to here, 10 power 1, how much? 10. See, 10 power 0 is 1, 10 power 1 means 10, 10 power 2, 100. See, 10 by 1. So, 10x by 1x. So, we can calculate x by 10x plus x. RCOH, how much value? 1. 10x plus x. X, 11x. Xx will cancel 1 by 11 into 100. How much? 9.1. This is the answer for that this question. How much, like in a duodenum, what percent of um, like aspirin will be the present in lipid soluble form. Here we have to understand it is a weak acid and medium is basic. It would be more in unionized form. So lipid soluble form it would be less. Here the question he is asking about how much it is. It would be 9%. How it is, I told you every step how to solve and everything. That's for this class. If you have any doubts or if you want to join to my pharmacology classes, you can WhatsApp me. Until then, bye bye.